Alright, implicit differentiation is a way in which you can take the derivative with respect to y for functions that are very difficult to isolate the y value. You can still take the derivative in a special way, and then you can solve for y prime. So here you've got a function that has solved for y, and same thing here, and we know how to take the derivatives with those. What about this one? This is a circle with radius 5 at center 0, 0. And it's a little difficult to solve this for y. You can, but if you solve it, you're going to have to take the square root, and you're going to be talking about two separate functions. The positive square root, which is the upper half, and the negative square root, which is the bottom half. We would end up be using, I believe, the top half based on what tangent point they want to use here. They actually end up using 3, 4, so they would be using this top half. Implicit differentiation means that we don't have to solve these functions for y. We can just take the derivative, and when you do this, when you take the derivative of something that has an x in it, you take the derivative just like you always did, so x squared's derivative is 2x. And when you take the derivative of y, when you take the derivative of y, you take the derivative just like you would for x, so the derivative of y squared is 2y, just like the derivative of x squared is 2x. But every time you take the derivative of y, you add on a y prime. And y prime you can also write as dy dx. So when you take the derivative of this, you get 2x, you get 2y, dy dx, and derivative of a constant is 0. And now you can isolate this guy, which is really your derivative of y, by bringing the 2x over, dividing by 2y, and now your derivative is negative x over y. And so we've taken the derivative of something that is complicated and isolated our y prime so that we can now find the equation of the tangent. Another way you can do it is you could solve it for y explicitly and then use only the top half, since your point to your tangent line is touching is on the upper half. And then you take the derivative and you end up getting the same answer. You get the same slope of negative 3/4, and you get the exact same tangent line. Now what if it's something more complicated like this one? This one, well, with implicit you get 3x squared, you get 3y squared, but then since you took the derivative of y, you tag on a y prime. When you take the derivative here, you got two functions, 6x and y, and so we're using the product rule. So the first 6x times the derivative of y, which is just y prime, plus y times the derivative of 6x, which is 6. And now you can isolate your y prime by bringing everything that has a y prime to the left, everything that doesn't to the right. We divide by 3 since everything has a 3 in it. We factor out the y prime, and now if we divide both sides by this number here, we get y prime all by itself. Now if you want to find the tangent, you just plug in your x and y into the function and you get your slope, and then you can find your equation of a line there. Part C asks you at what point in quadrant 1 is the tangent line horizontal. Well, you're looking where the first derivative equals 0. And we found the first derivative here. And when we set that equal to 0, we get the numerator equals 0. And we isolate it, we get y equals 1/2 x squared. Now since y originally is x cubed plus y cubed equals 6xy, we can plug in a 1/2 xy for y here and for y here. Then we have an entire equation just in terms of x. We can isolate our x, and we finally get all the way down here, and we get x equals 16 to the 1/3 or 2 to the 4/3. You can plug in 2 to the 4/3 into the derivative there, and you get 2 to the 5/3, and that's the x value where the tangent is horizontal. If you plug that into the original function and solve for y, you get this value for y. This is actually what we've been doing, is taking finding the derivative of the tangent at the point 3, 4 for this guy here. This is a very complicated function. It's called the folium of Descartes. And if you want to actually break it up so that it's actually a function and doesn't fail the vertical line test, you have to break it up into 3 parts. This first part, the second part, and the third part. Notice there's 3 parts to it that are right on top of each other. And so those parts have to be broken up into separate parts. You can actually solve it using the complicated formula for the solution of a cubic equation similar to a quadratic formula. But it's quite complicated, and this is what it looks like. Now, we also solved it a lot easier just by taking the derivative using implicit differentiation. Now, if you had something that's even a little more complicated like this one, it's impossible to solve this for y. So the only way you can really take a derivative of this in order to find y prime is to use implicit differentiation. All right, so let's take implicit differentiation for sine x plus y equals y squared cosine x. So you've got the derivative of sine x plus y is cosine times the derivative of the inside. Derivative of x is 1. Derivative of y is just y prime. On the right you got the product rule, y squared times the derivative of cosine plus cosine times the derivative of y squared, which is 2y, y prime. And now you do a little algebra. You bring everything over that has a y prime, you factor it out and divide by it. And now you've got your answer for y prime. On this one, if you want to find the second derivative, you first take the first derivative. So you get 4x cubed, you get 4y cubed, y prime, and you get 0. And now you can solve this for y prime. Okay? And now if you take the derivative of this, you get y double prime, which is the bottom times the derivative of the top minus the top times the derivative of the bottom. Notice when you do the bottom's derivative, you tag on a y prime all over y to the 6th. Now we know what y prime is, so you can plug that into there. So this is all in terms of just x's and y's. There are no y primes in there. So the second derivative of y looks like this. And you can do some simplification here, some algebra as we factor it down. And then at some point, if you can somehow get x to the 4th plus y to the 4th in your answer, we know that that equals 16. So you can replace this with a 16 and it dramatically simplifies your answer. Alright, now in 3.5 I'm not going to do the WebAssign questions in the order that they're found in the on your homework, but if you go to your notes on Canvas file, it's in the proper order. I'm going to do problems in groups of types of problems. So the first type of problem are questions 1, 2, and 3. They first ask you to take implicit differentiation, so you get 10x and you get 3y squared y prime, and you get 0, and you can solve it for y. Now then they ask you to solve it explicitly for y, and then take the derivative. Okay, and now they ask you to take the first answer you got and plug in using the equation. We know from the equation 5x squared minus y cubed equals 7, so you can solve this for y cubed, and you get 5x squared minus 7. And now if you can rewrite this so this is y cubed, you can replace it with the 5x squared minus 7, and you see that you get the same answer as that one. Question 2 asks you to do implicit, explicit, and then compare answers. So 6x to the 4th is 24x to the 3rd, 5x to the 4th y prime, and 2x is just 2. And now you can solve this for y and you get your answer there. Now here if you solve this for y, you get this, and now you can do an explicit differentiation and you get this guy here. So now you take this original guy and you use the first equation, and if you can get this to look like y to the 5th, you can say from your original equation that y to the 5th equals 2x minus 6x to the 4th, and you replace that with 2x minus 6x to the 4th, and you get the same thing you had when you did it explicitly. And the same thing with question 3. You can take the derivative here, you get 1/2 x to the minus 1/2, you get 1/2 y to the minus 1/2, and then you get a y prime after it, and derivative of 1 is just 0. And you can isolate y prime. You get down to here. Now if you do it explicitly, you solve it for y, and you take the derivative, and you get this guy here. Now if you take the original guy and use your answer, the original question, you can plug something in for the square root of y, right there, and you end up getting the same thing you got for part B. And so that's one way to show whether implicit or explicit, you get the same answer. Alright, questions 5 through 19 are of the same type. They're just asking you to do the derivative. So, derivative of 2x squared is 4x. Derivative of xy, that's the first times the derivative of the second, which is y prime, plus the second y times the derivative of x, which is 1. And then 2y, y prime, and then 0. And you solve for y there. Here you get 3x squared. And now here's the product rule. First, x times the derivative of y squared is 2y, y prime, plus y squared times the derivative of x, which is 1. And this one is 3y squared with a y prime. Anytime you take the derivative of a y, you tag on a y prime. Notice here we didn't take the derivative of y, we took the derivative of x. Okay, and you can solve all that for x or for y, and you get your answer. 4x cubed plus 4x cubed, and now the first is your x squared. Derivative of y squared is 2y, y prime, plus y squared times 2x, plus 3y, y squared times y prime equals 0. And you can solve that for y. Same thing here with 15. You take the derivative of y cosine is the first times the derivative of cosine, plus cosine times the derivative of y, which is just y prime. Derivative of x squared is 2x. Derivative of y squared is 2y, y prime. And you solve it for y. Another type of question is a question like 27 to 32. Let me see if I can find one of those. Yeah, 32. They ask you to find the first derivative using implicit, and so we do what we've done. And then they ask you to find the equation of the tangent line. So you just take your point and plug in for x and y, and you get your slope. And once you know your slope and you know your one point, you can find your equation of the line. The only one that we haven't covered yet is 39 and 42. In this one, they ask you to find the second derivative. So you take the first derivative, 2x, 8y, y prime, 0. Solve it for y, and you get this guy. And now take the derivative of this guy, and you're going to use the quotient rule. So you got the bottom times the derivative of the top, minus the top times the derivative of the bottom. Derivative of 4y is just 4, but tag on a y prime because you just took the derivative of y, over 4y squared. And you simplify that, and you're going to at some point have to plug in for y prime what you found y prime to be, and then simplify the whole thing down. Sometimes you have to multiply by a common denominator to get rid of your complex fractions. And if you want, you can also use your original equation. If you can somehow come up with something that looks like your original equation, you can plug in what it equals, which in this case is 4, and it dramatically simplifies your problem down. I think that's about it. If you take the derivative here, you get the first times derivative of the second. Remember, the derivative of e to the y is just e to the y, but you tag on a y prime. Plus e to the y times derivative of x, which is 1. Derivative of x is 1. Derivative of y is 1 y prime. And now you just solve this for y prime, and you get your answer there.